All right, good morning or good afternoon, ladies and gentlemen. Today we're going to go into chapter 3. So, my plan for the next couple weeks, chapter 3 is relatively easy and it builds off of the lesson we learned before we went remote. I know I'm kind of jumping around a lot here. The reason being is that I want to do the hard stuff in person. That way I can really focus on building those skills. So for today, chapter 3 is a lot easier, at least the first couple sections are, and it'll be a good way for us to kind of get back into the swing of things for math. So to give you a hint about what this chapter is all about, the whole chapter is called rational numbers. And if you remember our first lesson when we talked about different number systems, rational numbers was a set of numbers. So as a reminder about what a rational number is, a rational number is any number that can be written as a fraction. And where we get the term rational is actually from the word ratio, which means to divide. So it's no surprise that, say, like 3 over 4 is rational, because it is a fraction. But what about the number like 2 or 0 or -1? Can I write those as fractions? And the answer is yes. So these are all rational. How I can write them as fractions? So I can write 2. The easiest way I could do it is 2 over 1. But I could also write it as 4 over 2. For 0, easy, I could put 0 over 1. Now, some of you might be a little bit worried about that statement because you may have heard of dividing by 0 is bad. But the key thing is here is that we can do this, but we can't do this. That is what we mean by not dividing by 0. We can have 0 in the numerator because 0 divided by 1 just gives me 0. How many times can I split 0 into one group? 0 times. And then for -1, well, I could write this as -1 over 1. So I can always put something over 1 to turn it from a whole number or an integer into a fraction. What about for something like, let's do an easy one. So if I have a decimal, 0.25. Now, I picked this number because a lot of you can recognize what this is, and the answer to this is yes, it is rational. Because I can write this as 1 over 4. Okay, well, what about something like 0.3? And again, yes, I can write this as a fraction. In this case, I want to move the decimal place over once, so I can write it as 3 over 10. And another way I could write it would be 30 over 100. So there is a trick here that I move one place over. So I put it over 1 with 1 0 for how many times I've moved it. Or here, I've moved the decimal place over from 0.3, I went 1, 2 to get 30. So in this case, I would put 30 over 1 with 2 zeros, or 100. So that's not a problem. Now this is where it gets a little bit interesting. What about 0.333 repeating? A lot of you might say no, which is a good thought. How do I express a number that goes on forever as a decimal? Well, this is actually the definition of 1 over 3, or 1/3. Now, it seems strange, but the thing is that 0.333 is predictable. Because it repeats, I know what the 10th digit is, or what the 100th digit is, or what the millionth digit is. It's going to be a 3. So in this case, it is rational. So a takeaway is repeating decimals, or what we call terminating, or ones that end, are rational. So everything here is rational. Sorry about that. A number like pi, that's 3.14159, and it doesn't repeat and it goes on forever, this is what we call irrational. And the reason being is I can't write it as a fraction because it goes on forever and it doesn't repeat. So the only way that I could get to a higher and higher decimal place is by actually calculating it. So it is not predictable, so I can't say it is. So keep in mind, every rational number is going to be fair game for us in this unit. Now, there's a couple of things that we can work with. Section 1 is all about finding numbers on a number line. And we already did. We have a number line that goes up and down. So we have positive going up and negative going down. A lot of other books explain it as positive numbers are to the right. So anytime we go to the right, we have positive numbers. And then the further left we go, we hit negative numbers. Now, this is going to be important for locating different numbers. The key thing is, or one of the key examples is, use the less than or greater than symbol to write a true sentence for each of the integers. And this is something that we've done before. It's not super complicated. If we're comparing 3 and 7, which number is bigger? Well, 7 is. Well, how about -6 and 3? This is where things get maybe a little bit complicated. Now, 6 is a bigger number, but the thing is that it is negative, so it's going to be smaller than a positive number. So again, I'm opening this way. The way that I can think about this is that the less than or greater than symbols always open towards the number so the less than or greater than symbol always opens towards the number on the right or the one that's above on the number line. So for example, if I was to draw a number line, -6 is over here, 0 is in the middle, and then 3 would be here. So I'm going to open towards the one that's on the right. If I had a vertical number line, I would have 3 up here, I would have 0 here, and then I would have -6 somewhere down here. So again, I'm going to open towards it, so then I can rewrite this as -6 and then open towards 3. And I'll put the 0 on the other side just so it's a little bit clearer. So opening towards the one that's further on the right, and this is going to help for question D. So now I have, let's fill it out on the same line, I have -3 and I have -5. So they're both negative and I'm wondering what to do with them. Well, the same idea, I'm opening towards the one that's further on the right. Or in this case, I'm opening towards the most positive number. In this case, they're both negative, but -3 is closer to the positive numbers than -5. And we probably all are probably pretty comfortable with this. Where it gets a little bit more challenging is, well, I'm going to slide over here again. What happens if I look at something like 2.2 and 2.3? Now I'm adding a decimal.
In this case, again, it's not hard to see 2.2 is smaller than 2.3. Okay, well, how about 2.2 versus 2.22? Might be a little bit more of a challenge, but a lot of you will automatically see that there's a little 0 here that's not being shown, and then it's easy to see that 2.22 is bigger. Another way I can think about these, well, let me kind of throw a wrench into these. What about 22 over 10 versus 222 over 100? Now, one of the things that we'll notice is that fractions are not great for comparing size. And the reason being is that I don't have decimal places, I instead have fractions, and the fractions can be different. But again, the same kind of idea with what I did here, I can think of this with an extra 0 here and make them common denominators. So then I would be comparing 220 over 100 to 222 over 100. And again, it's easy to see. So one of the tricks is look for common denominators. And one of the things that some of you may have noticed is that these numbers here are actually the same. I can rewrite 2.2 as 22 over 10, and I can write 2.22 as 222 over 100. One final example of this, what happens if I have 2 over 6, or sorry, 2 over 7 versus 3 over 8? For something like this, again, I want to look for the common denominator. I can find 2 over 7, common denominator would be 56. So this would be 16, and this would be 21. And all I did to get there was I multiplied this side by 8 on top and bottom, and I multiplied this by 7 top and bottom. So common denominators will very easily help us find whether or not a number is bigger or smaller. The other part of 3.1 is finding values in between. And specifically, I want rational numbers. So for example, find a rational number in between 2.2 and 2.3. Actually, let's start simpler than that. 2 and 3. Now, one of the things about this unit is that between any two rational numbers, there are actually an infinite number of rational numbers. So this technically has an infinite number of answers, but a lot of you will gravitate towards some of the more obvious ones, like halfway in between 2 and 3, I have 2.5. And this is a rational number. It is a decimal that ends. I could also put 2.1 or 2.99999. It's again smaller than 3, bigger than 2. What about 2.2 and 2.3? Well, again, easiest way is to kind of split it down the middle. I would do maybe 2.25. That would work. Or I could do 2.223 or 2.2001. All of these are good. Where it gets a little bit more complex is for something like, let's do 5 over 8 and 6 over 8. Well, this one is trickier. I need to find a number that's in between. So option 1, I can always convert to decimals. So in this case, I can convert 5/8 and just turn it into a decimal with a calculator. And you'll notice, again, solving these as decimals is going to be really easy. So I can convert 5/8 to be 0.625 and 6/8 to be 0.75. So then it's easy to see a decimal in between these two numbers. I could do 0.7. And then if it asks me to do it as a fraction, I could do 7/10. The problem with this is if I have to find a fraction in between, then it's going to be potentially a lot harder to find if I convert to decimals. So then another option is leave as a fraction. So to do that, I can do 5/8 and then 6/8. And again, all I'm going to do is think about these little zeros. So I can rewrite these as 50/80 and 60/80. I haven't changed the values. If I check, this is still going to be equal to 0.625, and this is going to be equal to 0.75. So I haven't changed it, but now I've opened up a bunch of fractions in between, so my answer could be like 55/80, or it could be 52/80. And this way I have a whole bunch of options available to me. Another way you could do this is to just simply double everything. This was I multiplied everything by 10, top and bottom. But I could also do this as 10/16 versus 12/16. And how I would get to there is I'm multiplying everything by 2. And then from here I have 11/16 is the one that fits in between those. So keep in mind, there's a number of options for this, but one of the things you'll notice is generally comparing between decimals is easy, whereas fractions can be a bit of a pain. But it's helpful to know both because it might be something that I want to leave as a fraction because the rest of my problems are fractions, or I don't want to convert back and forth in between fractions and decimals. So knowing how to use both is important. So that's section 3.1. 3.2, I'm not going to go into too much detail. It's adding and subtracting rational numbers. The main part of it is this is sort of an alternative way to think about adding and subtracting. So the way they show it in this section is if I have, for example, -2 plus 5. This basically says start at -2 and then move 5 to the right. So if you have a number line, you're going to find -2. This is our start. And I add 5. So I move 5 spaces over, and then it equals whatever the number that I end up at. So I can have -2 plus 5 is equal to 3. And the cool thing is that this works no matter what. If I extend this out, so I have 4 and I have 5. If I instead had 5 minus 2, all I've done is rearrange the problem. I'm going to start at 5, and I'm going to move -2 units to the left. And again, I end up at 3. So it works no matter the order. And the 3 cases are if I have a subtraction, or adding, you move right towards the positive numbers, and then subtracting, you move left. And then lastly, if you add 0, you stay put. So that's these 3 here. Now the main reason why I'm going into this, a lot of these are simple. We know what 2 plus 3 is equal to 5, but there are sort of these couple of rules that'll help us out. The main ones are 2 positives and 2 negative numbers. adding two positives becomes more positive. So, for example, 3 plus 5 is equal to 8. 8 is more positive. It's further down the number line than the other ones. If I'm adding two negative numbers or subtracting two negative numbers, this becomes more negative. So it moves further left. So if I have minus 3 minus 5, I'm going to get to minus 8. Now, part 2 is if I have a positive and a negative number. So for example, if I have 30 minus 12. Now, we have a strategy that we've learned about before for dealing with this. I've lined up my ones and my tens columns, so my first thing was splitting it up like this. So then I have 0 minus 2, so I have to substitute and bring a 1 over. So then I end up with 8, and then I have 2 minus 1 is going to give me 1. So my answer, I have 30 minus 12 is equal to 18. Now, this works well and good unless I have something like 12 minus 30, where the number is bigger. Now it doesn't work. And to show you really quickly, 2 minus 0 gives me 2. 1 minus 3 gives me, well, negative 2, question mark? To put it simply, this does not work. Instead, think about it as negative 30 plus 12. They're going in the opposite direction. So I'm going to add 12 to 30, so they're going to go the opposite direction. So I'm going to treat this like a subtraction of negative 30, and I'm adding 12. So 0 plus 2, well, I have to bring this down, carry it, and I get an 8. Then I have 2 minus, or negative 2 plus 1, I have minus 1. Or the key thing is that I'm bringing the number down here. And I get negative 18. So the opposite, 30 minus 12 minus 30 is equal to negative 18. Why I'm bringing this up is that there is a symmetry here. So treat both like subtraction. Larger number on the top. And keep the sign of the larger number. So for example, if you have 10 minus 45, I'm going to think about it as 45 plus, or I'm going to think about it as 45 minus 10. I'm going to have 5, 3, and then I keep the negative sign here, so it's going to be minus 35. The reason why this works is that 30 and negative 12 are the same distance away from each other as negative 30 and positive 12. So there's the same number in between. So flipping the signs is going to give me the same difference between the two of them, just the sign is going to change. So keep that in mind. I see people jump in with this one all the time, and it still trips me up from time to time where I just have learned a procedure and I want to apply it immediately. So that is the main two rules for this. And again, one of the things I'll point out is that adding decimals doesn't work so well in a number line if you have to guess. So one of the things to keep in mind is if you have something like 3.42 minus 2.71, the main things are, number one, line up your decimal point. So notice how I've lined up my decimal point here, and then 2 subtract as normal. So 2 minus 1 gives me 1, 4 minus 7, I have to carry this over, so I have 14 minus 7 gives me 7, 2 minus 2 gives me 0, and again I'm keeping the sign from up here so it's positive, so there is my answer there. Now this is harder to see on a number line. The one other thing is if I had something like 3.42 minus 2.711, I still want to line up. I want 3.42 minus 3.711. The thing that I'm going to use to help me is there's going to be a 0 there. So from here, then I have to carry the 1 over. I get 9 because it's 0 minus 1, so I have to bring the 1 over. 1 minus 1 gives me 0. 4 minus 7, oh, I need to carry this over. And then 14 minus 7 gives me 7. Decimal point carries down, and then 3, sorry, that should be 2. 2 minus 2, 0. So I have 3.42 minus 2.711 is equal to 0.709. So keep in mind, that's one of the tricks, is if you have numbers to different decimal places, that you're adding zeros until they all line up. In any case, that's all I have for you today. Thank you so much for joining. I'm going to be posting an assignment that's related to some of these, but take care, stay safe, have a good one, and I'll see you in the next video on Friday. Bye.